The compute services are one of the first things that many people think about when they talk about the cloud. The compute services have many different components. Let's go ahead and break those down. To start with, you have the EC2 or Elastic Cloud computing environment. So this is really a virtual server, right? So this gives you the ability to spin up virtual machines. And then you also have AWS LAMBDA, which is one of the more exciting new components of AWS. And this is a zero administration compute platform. You can run code without provisioning or managing servers, and you only pay for the compute time that you actually use. So there's no charge at all if your code isn't running. You can just sit there and hibernate. You can use this with Python. You can use it with Go. You can use it with lots of different languages. And then also there's automatic scaling. So what this does is it scales the EC2 machines when you need them. So this improves your ability to use EC2 effectively and organize different workloads. Also, it's a way of ensuring that you have the correct amount of resources necessary to match the environment that you're in. Next here we have Elastic Load Balancer, and this is a way of distributing traffic, right? So let's say your ELB is here, and you can decide through health checks which machine you should route traffic to. Let's say that one machine has a lot of users on it. Let's say it has 40, and then another one has only 38. Then the ELB would look at a health metric and then route the correct traffic to that second node. Also, there's Elastic BEANSTAK. And Elastic BEANSTAK allows you to quickly deploy and scale and manage web applications. There's no charge for it. You only get charged for the underlying compute resources. So this is a platform as a service. We're going to get into that later. Next, there's also some new offerings like Lightsail. And Lightsail is a pretty interesting offering because what it does is it allows you to spin up things like a WordPress site. So if you don't want to provision an EC2 instance, set up a load balancer, manage all that, you can click a button and set up a WordPress site. And it has everything from SSD-based storage to data transfer to DNS management to static IP addresses, all set up and managed in this hosting environment. There's also Elastic Container Service, or ECS. And what ECS does is allows you to do container management and eliminate the cluster management infrastructure. So you can basically give a Docker container here to this ECS service and run it. We also have Fargate, which is an interesting service as well, which allows you to run a container without having to manage a server or a cluster. And so this is actually very compelling for data scientists, data engineers, people that want to take some maybe containerized application like a machine learning model and just test it out in the cloud. Fargate is a great solution for that. There's finally Elastic Kubernetes service. So this is Amazon Elastic Container Service for Kubernetes. And what this does is allows you to run Kubernetes without having to manage the complexity of a Kubernetes cluster. Kubernetes is a very complex system, very powerful, but by using this EKS service, you can offload that complexity to AWS. So let's go to this next section here and talk a little bit about this Elastic Compute Cloud. What is it? Why would you use it? Well, first let's break down some things about what is actually involved in a compute cloud. Elastic refers to the fact that if you're properly configured, you can increase or decrease demand depending on the servers that your application needs. Second, in terms of compute, this is really talking about a specific compute resource or server. And then cloud, this refers to the actual environment that it's running in. What are some things you can do with the Elastic Compute Cloud? You can do web servers, right? So that's one example. You can also do database servers. You can set up video games. You can also do things like machine learning. There's many different resources that you can use Elastic Compute Cloud for. And one of the big advantages of the Elastic Compute Cloud is that you can offload that complexity to AWS. So let's talk about a few other things as well you could do with this Elastic Compute Cloud. It has support for most server operating systems. You can also save and store something called AMIs. These are Amazon Machine Images, and we'll get into those. You can also add more instances whenever you need them. And you can also either launch one instance or you can launch a whole fleet of instances at the same time. And this is an automation capability that's built into many components of EC2. You also can choose what kind of machine you want, a CPU heavy machine, a memory heavy machine, a storage heavy machine, or potentially a GPU machine for doing deep learning. And also Amazon has support with EC2 of using these virtual private clouds as well. And the virtual private cloud allows you to have a firewalled off network that only your resources can actually get access to. Finally, there's security groups, and security groups allow you to specifically open up or close ports so that you can maybe SSH into an application, but specifically target it to one node that actually is the breakoff node where all of your traffic goes through. Let's talk a little bit about correct instance sizing now. This is one of the more important things to think about when you're using EC2. Amazon does use Intel Xeon processors, and these are really the high-end processors that give you a lot of value for what they pay for it. And these EC2 instances are optimized for different use case and workloads. So they come in lots of different sizes. And some of the things to consider are going to be, for example, core count. Like how many cores do you want on each machine? How much memory do you want when you spin up one of these things? Also, another one would be the size of the storage. So do you want a EC2 machine that has a large disk on it? Maybe you're going to be doing some data analysis. And then network as well. So this comes up quite a bit is do you want a very fast network connection? Maybe you want to do 10 gigabytes a second of network traffic. And then finally, there's also what kind of CPU technology do you want? Do you want the latest CPU technology because there's something you're going to exploit, or are you okay with maybe an average CPU capacity? Let's also talk about AMIs as well. So this is a really important feature of AWS, and this allows you to define an initial configuration and then use that to launch different instances. So with an AMI, some of the things that you can configure would be the OS, right? So you can go through and configure what operating system you want to have, maybe Amazon Linux. Another thing you can configure with AMIs is whether you want to have patches already pre-installed, right? So maybe you want to update a specific version of the operating system, and then also you can install things like maybe you want to install the latest version of Python. For example, you want to install Python 3.8, and you want that on all the instances that you launch. So it's a template that contains a software configuration that you can use on these instances, and when you make a copy of it, you can launch that copy all over the EC2 instances, maybe in your fleet. And you can also use different AMIs to launch different instances. Maybe you have a database server instance you want, or you have an application server you want. But the AMIs are really a way of copying a known good configuration and then launching things with that known configuration. Let's next talk about these AMI use cases here. So one of the reasons why it's important to think about AMIs is that you can use it to launch new instances. So you can, for your specific use case, you can use it to launch this configuration for maybe the specific type of application you've developed. You also can use it to copy that same image to a fleet of machines, right? So you could have maybe a deep learning cluster. And also you can deregister those AMIs when you're no longer using it as well. And let's talk about a specific workflow here of how you could actually use an AMI. So step one would be that you would go through and create an AMI, and then you would go through and make a template, just like you would have maybe a PowerPoint or a Word template. Then you would go through and you would register that next. So we'll call this the register phase. And then once you register it, this AMI is available. And this AMI, what you could do is you could then use it to launch an instance. So we'll call this an EC2 instance, but you also can then make a copy of it and you could launch a second instance as well. So really, you can think of it as a template to use to configure machines, and then you can either save that template or modify it and or use it to launch many other machines. Let's also talk about some instance types here that are available on the EC2 platform. There's really this general purpose type, which is often used, and those would be things like the M class here, so M5s or M4s, and those are just really a general purpose machine. You also have C5 and C4, and these are compute optimized instances. And then for storage and I/O optimized instances, you have H1s, I3s, and D2s. In terms of memory optimized, you have X1E, X1, and R4. And then in terms of GPU or FPGA enabled, and again, these would be for use of, let's say, deep learning or specialized workloads. These are P3, P2, G3, F1. So you can see that the P's stand for the GPU computes. And then there's burstable performance, which are used for specialized use cases like a micro instance, for example. So now that we know that those instance types are available, let's talk through some scenarios of how pricing comes into play. And this is really what makes an expert get separated from a beginner, is understanding these different components here. So to start with, you have the ability to have per second billing. And this is really important to know about when you're talking about, let's say, a reserved instance here. We'll call this one reserved. Or if you're talking about a on-demand instance, this would be just a regular instance. Or you're talking about a spot instance. All of those, you can actually get per second billing. So this allows you to scale up and scale down to based on demand. The other operating systems other than Amazon, Linux, and Ubuntu, like Windows, they don't have per second billing. Those are hourly billing, but so hourly for Windows. But what this per second billing does is allows you to potentially spin up 10 different deep learning instances, use those for 20 seconds, train a model, persist that model to Amazon S3, and then you've got this highly optimized cost scenario. Now, if you want to use a dedicated machine, and they have physical hardware as well, that is actually going to be per hourly billing. But this is a huge advantage of the AWS ecosystem, is being able to choose between these on-demand, spot, or reserved instances, and then also scale up or scale down those instances and only pay for those instances on a per second basis. And also some things to talk about in terms of per second billing are that you only pay for what you use. It again corresponds to on-demand, reserved, and spot instances. And you can use this scenario for irregular jobs, like a batch-based job that runs at night. And also this works in all regions and availability zones, and specifically corresponds with Amazon Linux and Ubuntu. Okay, so let's talk through here about some different pricing comparisons here and talk through some of those scenarios. So to start with, if you're talking about some of the benefits of these different kinds of instances here. So if you're talking about on-demand, just regular instances, these are fairly low cost and they're flexible, so you don't have to do anything too crazy to use them. Now with spot instances, these are great for large workloads and also a dynamic workload. So maybe you want to try out an idea. Again, maybe you want to scale some deep learning model that you think could improve the ROI of your company. You can try that out by using spot instances. With reserved instances, these are when you have a predictable workload. That's when you want to go through and use these reserved instances. And then dedicated hosts, these can help you save money on, let's say, licensing. Let's say you have a specific proprietary software package, or you may need to go through and meet some kind of regulatory compliance issue. Maybe it's a medical issue or something like that. So this is another use case for dedicated hardware. Now let's get into some actual case study scenarios here. So when, or use cases here. So in terms of why would you use an on-demand instance? Well, this could be for application testing, right? So maybe you want to go through and test out some kind of a configuration. So you're okay with using some on-demand instances. Spot instances are really good when you have a start and end time, right? So you know that you want to run a job maybe at night, and then you want to run it for 6 hours, or if you actually want to expand your capacity very quickly, that's another use case for it. So these are really good for irregular type of jobs. Now, reserved instances, this is really the scenario where most companies should get to, is that you know what your capacity is and you have a steady state that you're going to run in, and you actually then go through and reserve the capacity you need. And also this allows you to save on compute costs because you can reserve and buy in bulk, basically. So this is knowing what it is you need to use and then getting a huge discount by doing reserved instances. And then again, for these dedicated hosts, this would be for something like BYOL, or bring your own license, compliance, right? We talked about that just recently. And also things like controlling where your instance is actually placed as well. So maybe you have some very specific performance requirements and you want to have a very specific location that you want your hardware to live. Okay, let's talk through some pricing considerations as well, and some pricing considerations to really consider here are that things like how many hours you're going to be using your resources. So let's start with that. So let's say, how many hours are you going to be using? This is something that will go into deciding what kind of instance, also what kind of instance. So what's the config? So are you going to be using, for example, maybe CPU heavy instances, or are you going to be doing memory intensive configuration? And so that how many cores are you going to need and how much memory you're going to need? So that's one consideration. Another consideration as well is what kind of purchase price are you going to be using? Are you going to be using, again, a spot instance or an on-demand instance, or what kind of instance are you going to use? Because that's going to go into the total cost scenario here of what it is your monthly bill will be. And then what about how many you're going to have? So are you going to have a cluster, or are you going to have one instance? Right, so the total number of nodes goes into the pricing consideration. Also, load balancing. Load balancing comes in. Do you need to have some spare capacity because you want to have a very reliable and elastic configuration? And so, how many do you actually need? That's another consideration. And then, in terms of monitoring, these are costs that you have to be aware of. That there is a very modest cost to monitor. So are you actually monitoring your ecosystem, and what's that cost going to be? And then also auto scaling, right? That's another component, is that when you do get new workloads that go up or down, how does that affect your cost? And then elastic IP as well. So if you're doing hosting of, let's say, a website, or you need a publicly addressable domain name, you may associate an elastic IP address with it. And then finally, another thing to consider would be, what about the actual cost of your operating system? Are you running Windows and there's a licensing fee, or you're running, let's say, Oracle or something like that? There's going to be pricing considerations. So these are all things to think about when you're dealing with the AWS EC2 ecosystem. So let's now get into another interesting feature of EC2, which is spot instance hibernation. One of the things that you can do by using these really inexpensive spot instances is you can actually hibernate your spot instance by saving it over to the EBS system. And so EBS stands for Elastic Block Storage. And EBS will allow you to keep track of your instance. So it's almost like closing your laptop lid, you're closing your laptop lid, and then you can resume that service once the instance is spun back up again. So this can really be helpful in cases where you have maybe critical applications that you wanted to spin up at a certain interval, or you want to save on cost, right? You don't want to rerun a job that was terminated, because spot instances can be terminated. So this is an important consideration to be aware of with spot instances is do you know exactly the use cases here for a spot instance, and can you configure it to your particular workload? Let's talk through some cost optimization issues as well. Some of the things that come up when you're doing cost optimization with EC2 is, are you using the concept of right sizing? So are you using the correct instance for the workload you're running? So are you using maybe the correct number of cores or the correct number of instances? So these are all things where CPU, memory, size, these all come into play. And then what about reserved instances? Are you actually using the reserved instances when you know you have, let's say, a long-term workload, right? Are you saving this 75% off reserved instance price discount? And then what about elasticity? Are you actually monitoring things, and are you using the auto scaling capabilities? Because these are ways that you can shrink your cost, right? When the workload goes down, you can shrink. And then finally, are you looking through and monitoring your applications? Are you using data? Are you doing data-driven cost optimization? Let's talk through about how this right sizing here can really save you money. So one of the ways that it can save you money is that you're picking the right type of configuration for what you're running. So on demand, again, this is for spiky workloads. So this is when you should be using on demand. When you're using reserved, this is for dedicated, right? So let's say you have a database server, you know you're always going to need that database server with a certain amount of capacity. And then also spot, this would be for time insensitive workloads, right? So again, you want to try out experiments. Maybe your data science team wants to spin up things on demand. You could use spot instances for that. And then for dedicated, this is for highly sensitive workloads, right? So again, maybe a medical records or some kind of government workload where you have to decide exactly where it needs to run. Now let's talk next here about this other driver of cost here, which is reserved instance. So one of the things you can do with this is you can save, again, 75% from your workload, which could be a substantial reduction in how much money you're going to pay for Amazon. And you can use this for EC2. You can also use it for RDS, their relational database service. You can use it for Dynamo, the key value database system. And you can also use it for Redshift, the data warehouse. And you can use it for things like Elastic Cache as well. And Elastic Cache is a low latency cache-based service. And so the commitments are either going to be 1 year or they're going to be 3 year. And obviously the 3 year is going to be the one where you get the largest savings amount. So this is really important, and depending on what it is you want to do, this can really save your company a lot of money. And really this comes into play with more mature, larger organizations that know exactly what it is they're going to do. Okay, let's get into this third cost driver here, which is elasticity. So one of the things that is important to do when you're thinking through these elasticity problems is that, for example, do you use the instance when you need it, or are you turning it off when you don't? And so this is really just like a home with a thermostat. Are you actually efficiently using those resources? So this is a really big, important consideration with elasticity. And also, are you actually able to turn off non-production instances? So like the dev environment and the test environment, are you constantly running that 24/7, which is a pretty bad scenario because your developers, maybe they only work from 8 to 5 unless you have a 24-hour company. So why not hibernate that at night? And then also in terms of production. So, are you able to scale up using ELB to different nodes here and then scale back down again when you have spikes? Or are you constantly running a high workload and paying, let's say, 10 times more than you need to? So really, another thing to consider as well is that you should have something like 20 to 30% of your instances run as demand or spot, right? And so the other 80% should be reserved. And this is really an important consideration that is not as widely used as it should be. Let's also talk about another driver of cost, and that's going to be the ability to monitor your workload. So are you actually going through and monitoring things like tagging who is using what resource? That's one thing you can do with AWS. You can also identify non-production systems, right? So it's really easy to turn on a machine and forget you turned it on. Also, the ability to downsize. So, maybe you started off with an 8-core machine, and then it turns out that actually it only uses about 2 cores. So maybe you need to downgrade that to 2 CPUs. And then also identifying which instances should be converted to a reserved instance. Again, that ratio of 80-20 where 80% should be reserved instances. And then also looking at consolidating the billing, right? So if there's lots of different billing systems, it might be hard to figure out exactly what's happening, but you can consolidate your billing. And then also there's reports on savings. So there's a cost savings calculator inside of the billing system that you can use to take a look at this. So a lot of it is really about measuring, monitoring, improving what you're doing with EC2. Okay, let's talk about a new service on AWS called LAMBDA. And what is LAMBDA? Well, it's a fully managed serverless compute environment. You can do things like event-driven execution. So that's another really powerful thing about LAMBDA, is that it really opens up a different way of writing code. It's one of my favorite ways to write code. You also have sub-second metering, right? And so you're actually charged at the sub-second level, right? So you can save a lot of money this way. And then your functions are typically limited. You typically want to limit your functions to around, let's say, 5 minutes or so, although they constantly change how long they let that run. And then multiple languages are supported as well. So again, Python, Go, Ruby, Java, C#, tons of different languages here. And the big advantage here as well is that you don't have to manage these server environments. So what are some of these advantages of LAMBDA? Again, big advantages, no servers. That's a huge one, is that you don't have to spin up an EC2 server. You just write code. You also can have continuous scaling. So the scaling is really done automatically for you. You can write a function and it'll automatically figure out how many of those instances behind the scenes to spin up, and each one can run, let's say, 1,000 in parallel. And also, because there's the ability to do sub-second metering, you really don't have to worry as much about the cost infrastructure, because you can very efficiently write code that utilizes those sub-second requests. And really, LAMBDA is a new way of developing that's called a cloud-native way of developing applications. And we're going to do a demo in a little bit that goes through some things you can do with LAMBDA. So how do you get started with LAMBDA? Really, and we're going to demo this, is you can upload your code to the LAMBDA console, or write it right in the LAMBDA console. You can then set up, let's say, a trigger. And there's lots of different triggers on AWS. And again, we'll demo these. The triggers could be S3. They could be an API. They could be a timer. They could be a CloudWatch timer. And then the code is only run when one of those triggers is actually selected, and that makes it very, very efficient. And then finally, you only pay for when you actually use that service. So it's much different way of thinking about writing code, because it's based on an event, and the events are completely within your control. So what are some use cases for Lambda? Well, a bunch of different use cases could be that you, for example, run your code in response to events, and that's a pretty big one because there's events all over AWS. So let's talk about what some of those events could be. You could upload something to S3, like an image, and then you could have something process that image. You could respond to a table in DynamoDB. You could respond to a web request. So you could have an API triggered according to this. You could create a website, which we covered earlier. You could build full serverless applications, and you could use some of the more sophisticated application functions, for example, the AWS step functions to orchestrate multiple Lambda functions. And so in general, the use case is almost anything you can think of on AWS can somehow involve using a Lambda function. So let's go through and walk step by step through one potential Lambda example. One would be that step one here, you have a user capture some kind of an image, right? So here's our image, and they capture that on a mobile phone. That image goes through a mobile app, right? And it goes through and it puts that mobile image into Amazon S3, into a bucket. And then from there, what happens is as soon as that image is placed in the bucket, you have your Lambda waiting to process a request, and it gets fired. And then when that Lambda gets fired, it sends that over to, let's say, a natural language processing or a image recognition API to get metadata about that image, right? So it can maybe make a couple different API calls, and then when it gets those API calls, it could put the results into a DynamoDB database, and now you've got some metadata about that particular image workflow. So it really is a way of extending and enhancing workflows by responding to events. Okay, what about Elastic Beanstalk? Elastic Beanstalk is a platform as a service offering. So it's called a PaaS. And a PaaS is powerful because it also allows you to really focus on writing applications, so you can quickly deploy, scale, and manage web apps. It reduces the complexity. And so, but it does one different thing in that it does allow you to keep some control. So you can control, for example, the kind of instance that's associated. You can choose the database. You can also set up auto scaling capabilities. So it's really a kind of a medium ground between a Lambda and EC2 server. And so it's a platform that you can develop applications on. Also, it supports a variety of platforms. So anything from, let's say, Go to Python to Java. And also what it does is it supports the actual frameworks that are popular on those platforms. And again, there is no charge for it. You're only charged for the underlying compute resources that Elastic Beanstalk itself manages. So let's unbundle Elastic Beanstalk a little bit here and talk about what it actually is and what are the components. So what it provides is that you have your code here, and then underneath this code here, so we'll just make this code the block here. This is our code. You have application services. And then below that layer, what you have is a web-based layer, so an HTTP service. And then below that, you actually have the OS layer. And then you actually have a language layer. And then finally, the last part is you actually have the host itself. So really, it's a way of packing a whole environment together, and where you, even though these services exist here, the application service, the web service, the operating system, the language, the host, you're really focused on writing this code, and that's all you need to focus on. So why would you use Elastic Beanstalk? What are some of the benefits of it? Just really, it's that it's fast. That's a big one. Is that you can focus just on writing software. Productivity, developer productivity, right? So a developer can focus not on being an operations person, but just writing software. And also, you don't have to worry about outgrowing it, right? You can not worry about having to rescale your application or configure it. It's going to be completely able to scale up by using Beanstalk. And then also you have more control by using a pass. So you can tune the knobs and you can change different things, select databases, load balancers, firewalls, things like that. If you need to, you can configure those things. But in a nutshell, it's a nice balance between completely controlling something yourself with EC2 or going all the way to something like serverless where there's no servers to manage at all.